Okay, in this presentation we're going to look at solving complex equations and stuff like that. So essentially what we have here is a very simple expression, 3 plus 2i, and that is a root of z squared plus p times z plus q is equal to 0. Okay, so 3 plus 2i, and it is a root of that expression there. So the question asks us to find values for p and q. And importantly, it tells us that they are real numbers. They are not complex numbers, okay? And in fact, they might even be integers. We'll see, okay? So we'll start off with this expression here, and we'll let z equal to 3 plus 2i, as we're told in the question. And what we'll do from there is we will evaluate z squared. So z squared equals 3 squared, which is 9, plus 2 times 3 times 2i, so that is 12i, okay? And then 2i squared, or sorry, 2i to be squared gives us 4i squared. Okay, so put a little dot in there. So just as you should recall, 4i squared actually will become minus 4, and so 9 and minus 4 together will give us 5. So we end up with 5 plus 12i. Okay, so what we're going to do here is we're going to put it in this expression here, and we're going to substitute that in for z, and then find the values of p and q. So we have z squared, and that was 5 plus 2i, 12i even, okay? P times z, which is p times 3 plus 2i, and then q. And all of that is equal to 0. Now, importantly, that is 0 plus 0i, okay? 0 plus 0, or you can write it as 0 plus 0i. But that means that the imaginary component is 0, okay? So remember that for later on. So let's just sort of like simplify. So let's just go back to this expression here and simplify it out, or try and sort of work it out a bit or rearrange it. 5 plus 12i plus 3p plus 2pi plus q is equal to 0. So essentially what we're going to do is we're going to group up all the real terms there. 5 plus 3p plus q. And then what we'll do is we'll gather up all the imaginary terms. Okay, so we have the imaginary terms here, and we have the real terms there, the real components there. So essentially what you should recall is that they're both equal to 0. So 12 plus 2p is equal to 0. So necessarily p is actually equal to minus 6. Actually, I have it just written out here. Okay. And so necessarily if p is minus 6, 3p is minus 18. So we have 5 minus 18 plus q. Necessarily q must equal to 13 for all of this to be equal to 0. Okay. So that is that question done, and yeah, we'll leave it there.